4. So 4 and 17 really look like the same shape. So 4, state the most specific name for each figure. So we do know for sure it has 4 sides. Do we have 2 sets of parallel sides? Does it specifically say that we have 2 sets of parallel sides? So we can't say it from that. So are the opposite sides congruent?
No.
Are the opposite angles congruent? So because if it doesn't say 2 sets of parallel sides, our arrows, we can't say it that way. But if the opposite sides are congruent, then we can say it's a parallelogram. If the opposite angles are congruent, then we can say it's a parallelogram. Now, if all 4 sides have been congruent, then it'd been a rhombus. If we have 4 right angles, then it is a rectangle. If it has 4 right angles and 4 congruent sides, then it would be a square. Well, '17 is essentially the exact same shape. Yep. For a rhombus, all 4 sides would have to be congruent. Which one? This is what we have, yes? I mean, the arrows are going the other direction. So it does have 4 sides, yes? Do we have 2 sets of parallel sides? Do we have opposite sides that are congruent? I don't think it tells us anything about the sides except for those 2 being parallel. Now, are the top and bottom, the one sides that are parallel, are they congruent? Or do we have any information about any of the side lengths? I mean, besides that those 2 are parallel, that's all we know. If the 2 sides, or the set of sides that are parallel, were congruent, we can say it's a parallelogram. Because by our opposite congruent and parallel sides theorem, we can say it. But here, all we can say that this is quadrilateral. Arrows are just telling us a set of parallel sides. Any other questions on the homework? Special parallelogram properties. And that's what we're going to be looking at today, is more of the properties of the special parallelograms. Now, the first 2 we have are these here. The rhombus diagonal theorem. A parallelogram is a rhombus if and only if its diagonals are perpendicular to each other. So the diagonals in a rhombus will intersect at right angles. So whenever we have a rhombus and the diagonals bisect each other, they're going to bisect each other at right angles. So all these angles are going to be 90 degrees. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. All right, guys. So the other part of the property is that the diagonals bisect a pair of opposite angles. So they're going to bisect the angles. Well, we know the opposite angles are what? Congruent, yes? So that means, as it shows in the figure, these 2 angles are going to be congruent as well as these 2. And all 4 parts will be congruent to each other. The same with the other 2 angles. So if we look at the first example, find the measure of the numbered angles in the rhombus. So we want to find the measure of angle 1, measure of angle 2, measure of angle 3, and the measure of angle 4. So we're finding 4 angles. Which one of these angles do we know for sure? So we know 61. Which one of the numbered angles? What's the measure of angle 1? Okay, let's find the measure of the numbered angles in the rhombus. A parallelogram is a rhombus if and only if its diagonals are perpendicular, form right angles. So since this is a rhombus, those two diagonals are going to be perpendicular. So the measure of angle 1 is 90. So opposite angles are congruent, yes? And they bisect each other. So if this angle here is 61, what's the other one going to be? So those two have to be 61. We don't necessarily need that at that point. Because the opposite angles are congruent. They're going to be the same. So the only way that both of these and both of these can be the same is if they are both 2 and 3 are both 61, and the bottom two are both 61. Question? Yeah, because if this is 61 degrees, we have a triangle, so those three have to add together to be 180. So x plus 61 plus 90 is equal to 180. So this here would be 151. And if we subtract 151 from 180, we get any questions on these here?
How do you get rid of this?
90 plus 61?
Oh,
Mhm.
never mind.
You're good? Any questions on how we found the measures of angle 1, 2, 3, or 4? Still good with these here? Use the diagram in example 3 to find the measure of ABC and the measure of ACD, or ABC and angle ACB. So this here, we already said the measure of angle 1 is 90. 3 and 2 are both 61, and angle 4 is 29. So those we already found. What we want to find is the measure of angle A, B, C, so the whole angle, and A, C, B. Well, we already found one of them. What is the measure of angle A, C, B?
61.
61. Because we know that the diagonals bisect the angles, so they cut them in half. So if one half is 61, the other half has to be 61. Right. Because again, these angles are congruent. So if these are congruent, cut in half, these are congruent. So 29 plus 29 is, the measure of angle A, B, C is, which means this whole angle here is questions on this here? We ready for the next part? Yes? In example 3, what is the measure of ADC? ADC, yep. Measure of angle BCD. Yes. Questions on this here? So we know angle 4 is 29. The other angle is 29. Any questions on this so far? We good with this here? Now, before we move on to the next piece, if we look at this figure here, Oh yeah, find the measure of angles. No, I already did that. If we look at this here, find the measures of the numbered angles in the rhombus. Well, D, E, F, G. We're already not worried about that. This here we said is 58, and this angle here is 58. We already said that, yes? We said also that this bottom angle is 122 degrees, which means the top angle is also 122. If we add all four of these together, what would we get? Because 8 plus 8 is 16, plus 2 is 20. 1, 2, 3, 4, 5, 6, and 10. How do we know it should be 360? Four-sided figure? Yeah, parallelogram also. As all four-sided figures, quadrilaterals, the interior angles add up to be. Because that's still going from our n minus 2 times 180. So the interior angles of a four-sided figure has to be 360. Questions on this so far? Questions on anything else we've done so far? So let's look at this next one. Find the measures of the numbered angles in the rhombus DEFG. So we want to find these here, yes? Since this is a rhombus, this diagonal DF, bisects the angles, yes? Cuts them in half. Well, we know angle D, the whole angle D and the whole angle F are congruent to begin with, yes? So if they're congruent and cuts them in half, we know that the measure of angle 1 and the measure of angle 3 are going to be the same. They're going to be the exact same. So we could call angle 1 X. We can call angle 3X. And these three angles will add together to be half of it. Yeah. So we can use 180. Now we could use 360, but we would have to add it again. Because we could use 360, but we would set angles 1, 2, 3, and 4 as X, and angle G and E as 118. Now for the 180, X plus X is 2X. Now from here we need to get X by itself, so we would minus 118 from both sides, because 118 minus 118 is 0. And 2X, 180 minus 118 is 62. Then we would by 2, telling us that X is 31. So the measure of angle 1 is measure of angle 2. 31, because all four of those are going to be the same. Measure of angle 3. Measure of angle 5. Well, there is no 5. Yeah, there's only 4. But each of these here, so 1, 2, 3, and 4, all will be the same measure. They'll all be 31 degrees. If it asked for the measure of angle E, it would be what? 118. Opposite angles of a parallelogram are congruent. Opposite angles of a rhombus are congruent. Now, if we set it equal to 360 here, like we did on the whiteboard, this here would give us 4x plus 6. 236 is equal to 180. Yep, what's that? 8 and 8, 6, carry the 1, 2. Yep. This is off. I think where it's off. That's 118, x. Ah, no. Yeah, the math is off. 124. I was forgetting the last digit. And if we divide by 4, 30. Yeah, 3 minus 2. So we get the exact same thing, just the numbers are a little bit bigger. Questions on this here? Our next theorem, the rectangle diagonals theorem. A parallelogram is a rectangle if and only if its diagonals are congruent. If and only if its diagonals are congruent. And they are going to bisect each other. So, knowing that there, you're building a frame for a window. The window will be installed in the opening shown in the diagram. The opening must be a rectangle. Okay. Given the measurements in the diagram, can you assume that it is a rectangle? So for it to be a parallelogram, the opposite sides have to be congruent, yes? Because a rectangle is a parallelogram, so yes. So that means the opposite angles are congruent. And for it to be a rectangle, what else do we need? Can we say those 4 angles are right angles? How? Right. Because do we know what they are? No. Because it looks like they're right angles, yes? Yeah. Or 89. So, right, we can't because we don't know that it is a rectangle, because by definition, a rectangle has 4 right angles. We can't tell this has 4 right angles. So no, we can't assume it. No. Can't tell the angles. The angles are right angles. Can't tell the angles are right angles. Because unfortunately, they might be incorrect angles. Yeah. Questions on this so far? Because we're going to have a few more questions about this window. Now, same window. You measure the diagonals of the opening. The diagonals are 54.8 inches and 55.3 inches. What can we conclude about this opening? Yeah. It's not a rectangle, because our last theorem that we had was what? The diagonals of a rectangle are? So since the diagonals are not congruent, we can say this here is not a rectangle. Yes. Because it is a quadrilateral, because it does have 4 sides. And since the opposite sides are congruent, it would be a parallelogram.
But if you were to put a window in that, you wouldn't be able to tell.
Right. The biggest, it's because it would be close. The only issue would become, I think probably, because I'm taking a step out there, I'm not a contractor. It would be making sure that it does fit. It would probably be close enough to fit the window, but you'll have some issues with sealing. Making sure it's sealed properly so you don't let heat out. Yes. Yeah. Yeah. Small things. As we know, the opposite angles are congruent. So this angle has to be 90. So can we conclude it? Yes, because we know the opposite angles in a parallelogram are congruent. So those two are 90. We know the consecutive angles add together to be. So if one of them is 90, the only way we can have 2 angles add together to be 180, and one of them is 90, is that the other has to be Opposite angles. Can you conclude that the shape of the opening is a rectangle? Yes. All angles are right. Questions on this here? Suppose you measure only the diagonals of the window in opening, example 4, so here, and they have the same measure. Can you conclude that the opening is a rectangle? Well, yes. The theorem we just had a minute ago, well, not exactly a minute, our diagonals of a rectangle are congruent. If it's a rectangle, the diagonals are congruent. So if they said the diagonals are congruent, then it has to be a rectangle. Questions on this here? And this here is actually helpful because some of the stuff we cover is not as helpful as others, but this here, where we're trying to measure an angle, and if you don't have a protractor and you can actually measure the diagonals from point to point, we can actually verify that the angles are right angles. So it's kind of a helpful thing. In rectangle QRST, QS is equal to 5x minus 31, and RT is equal to 2x plus 11. Find the length of the diagonals of QRST. Yes, so this one here, we haven't done this in previous problems. I'm going to do this for this one, and then we'll kind of not do it in the next ones, because it's understood. So if it's a rectangle, we know the diagonals are congruent, yes? So mathematically, if we were doing this by the pure mathematical rigor, we would say that QS is equal to, well, we'd say that they are congruent. So we'd say the line segments are congruent. And if the line segments are congruent, it means that QS is equal to RT. Well, what is QS? 5x minus 31, and RT is? And really in all of them that we've done, especially this chapter, we have not written this out. We have not written this out in quite a while. But we know that's true. Because since the diagonals are congruent, we know that means that they are equal. And for this problem, it means that 5x minus 31 is equal to 2x plus 11. Now we just need to solve for the value of x. Because once we find the value of x, then we can actually find the diagonal's length. So we can, yes, we can minus 2x from both sides, which will tell us that minus 31 is equal to yes. Minusing 11, it's not that it's incorrect. If you do that, you will need to make sure, because then we would have to add it back over. Okay? Because that's something I've been meaning to bring up, because you can minus it, but I've seen y'all do that a few times, and then set them on the opposite sides. We would need to add 31. Three goes into 4 one time. Questions on this here? So, plug it back in. Which one do we plug it back into? The diagonals. Yeah. We want to find the length. Yep. A diagonal is a line that connects two non-consecutive vertices. So vertices are the points where the two sides meet. So yeah, for the most part. Once we get more than 4 sides, it's not diagonals, doesn't quite fit, because we can have more than one.
So if it turned into because 13 sides, how would it like snake over?
You went from
Mhm.
4 to 13.
So non-consecutive, as long as it's not a point to the immediate sides.
Okay.
So you get multiple. And there are formulas to actually figure out the number of diagonals that a figure has. Not really. It's once you know the formula, it's just plugging in the number of sides. 2 times 14 is 39. Well, if we use the other formula, 5 times 14 minus 31. 5 times 14 is because the diagonals are congruent, they're the same. So no matter which one we plug it back into, we should get the same value. So again, if you do one of these here, most of these where we're solving and the sides are congruent or the lengths are congruent, and you feel like the number that you get looks really weird or doesn't seem like the correct number, plug that value of x into both equations. Because if it gives you the same value for both, then that is the correct value of x. If it gives you two different values, then it's not the correct value of x. So it's an easy way to check your answer. Questions on this here? Are you ready for the next one? So here in rectangle ABCD, AC is 7x minus 15, and BD is 2x plus 25. Find the length of the diagonals. So to find the length of the diagonals, we need to find the value of x. Well, we know that these two diagonals are congruent, so it means that they're equal, which tells us that 7x minus 15 is equal to 2x plus 25. Now the first thing we can do is, we can minus 2x, we can minus 7x, we can add 15, we can subtract 25. Just pick which one you want to do. All right, so subtract 2x. But the biggest thing with this here is that we make sure that we end up with the x's on one side and the numbers on the other. That's what we're trying to get to. Now at this point here, we can add 15, which will tell us that 5x is equal to Now we need to plug it back in. Does it matter which one we plug it into? No. Which one would y'all prefer to plug it into? 7 times 8 minus 15. Well, 7 times 8 is 56 minus 15 is, so the diagonal length is 41. And really, we don't have to step that out one at a time, because once we get 7 times 8 minus 15, plug it into the calculator, let it do it. Yeah. Questions on this here? Questions on any of this so far?
Mr. McClanahan, can you do this?
They're very competitive. Do you think no?
Do we feel comfortable with these here?
Yeah. Yes.
And that's it.